Everyone, I've got my components now and I've finished it off, and I just want to mention a few things about the components, what I've done, bit of show and tell. So the LED is quite high. I've set the base sort of flush with the nano. That's so that when I get when the lid's on, it's going to sort of pop through and just show at the right level there. You know, let's just get that right. There we go. So it lights up. Definitely want that warning light. And I also wanted to mention about the power supply. I've designed it, the contacts to line up exactly with the contacts of this type of power supply. These voltages are the range, because it's a nice little power supply. You can put 50 to 270 volt in AC, or 70 to 390 DC in, and get the 5 volt out. So I quite like them. This header file here, headers here. This you want to, if you don't have a 3D printer, you might just want to put this in a standard box, and you might want to actually fix this in the lid, the encoder. So you can just attach wires, and you can use this header here as a socket for the wires from the encoder to plug into. This is my display header. Basically I've designed it so you just fit a female header on here, and then rather than just push that on there, it'll be quite fine. Let me just try and keep everything in shot and do it at the same time. You can see it's not quite stable if you push on the outside, so if the lid was on and you wanted to clean it, wipe it, you have a tendency to push down. So what I've done is I've made this little standoff. This is support for it. So if I just put the support on first, and then we just push it back on there, basically it keeps it flush with the back side of the lid. This capacitor, I've just put a normal capacitor in there. I haven't put the electrolyte one in there. Didn't need it. The only reason I put it as electrolyte was because that's what I used in the original version that I made. So there we go. And while we're on, what I'm going to do is I'm going to just test this before I box it up. So to test it, I've just put an LED. This is where the hot plate wires go in, the two hot plates. So basically what comes out of here is the mains, but it turns it on, and it only turns it on for fractions of a second. So I've put an LED there so I can see that it's lighting it up, just to check the circuitry before I box it. So I'll just place that down on there and clamp it in place. The other thing I want to mention is in the write-up I mentioned that this cable here, I don't know if you see it, this cable is the offcut. Basically what I did was I bought two of these, and what I did, I removed the end and then I cut it down to size. That's just the old sheath. Cut it down to size. So what I ended up with is an offcut, and this is the offcut from it basically. And all I've done, I don't know if I can get that into focus, but all I've done is I've just twisted the ends around on the end there. I warmed them up hot and twisted them so I get a right nice tight twist. So I don't know if that's in focus. Anyways, I just wanted to show you that you know you could use your offcuts, because the temperature that we're getting to on this isn't hot enough to break this twisted wire. You know, it doesn't expand enough because it's not glowing hot. The reason they weld them together is because you can use it for checking temperatures of really red hot steel or something like that. So I'm just going to test it with that. So what I'll do is I'll plug it in. Oh, and the other thing, I've made two versions of the PCB. I've made a later version where I've moved all these across and I've put a fuse in because some people wanted a fuse. I mean, there's no more danger with this than there is with one of those hair straightener hot things, basically. But in the UK, that's my plug, and there's my fuse in the middle. So that's why I forgot about it. So I'll just plug it in. There we go. Can we see that? I think so. So there's a little green light on the power supply. That's telling you we've got power. I put a green light for power on this PCB, and next to it there's a blue LED which tells us when the trigger is on, and that's on, the trigger is on the 5V side, this one, and obviously this test LED is on the main side, so that these two should flash at the same time, and then obviously my red one should come on when it's too hot. I don't want to touch the mains, but let's see if we can just see that. So basically that's set at 9V. Let's just rest it on the case, you see it better, and then we've got the end here. So first I can check the temperature. It is warm here. My other temperature says are saying 19 and 22, and well, we're in the middle of the other two temperatures I've got here. So if I put my fingers across here, we should get about 30 something, shouldn't it? So if I just hold that in my fingers, oh look, there we go. So I know my temperatures. This is working. So it just shows that just twisting these wires together does work. In fact, what I'll do is I'll get me torque. Oh damn! Just kick the forgot to get this. Yeah. Yeah, so here we go. Main shot, yeah. There we go. Oh, 750. So that sorts that out. Let's put that over there so it cool down. Right, so if I let that cool, well, let this end cool down first. Oh, and you can see the red lights on now because, well, so oh, it's gone off now. It's dropped below 46. So that bit works, and now we just need to test that the LED comes on. So if I turn it up above 29, our target, so if I put our target up to say 40, no, well, it's 48 there, you can see it flashing, because as it switches it on and off to try and warm up the PCB, which isn't there. So basically that'll just keep doing that until this, if I turn this down to say 30, right, so basically it's at the room temperature is 24, and it's trying to get this up to 24 degrees, which it isn't going to do because they're in a heater element. There's an LED, but if I put my fingers on, that brings it above 30, and now this should reduce, and we now know the circuit's all working fine. So I just thought I'd do that video just to point a few things out. Hope you enjoyed. Thank you very much.